What currents flow through the 1 ohm resistor? What's the voltage drop across the 1 ohm resistor? How much power is dissipated in the 1 ohm resistor each second? So we are going to find the equivalent resistance firstly. And we are going to find the total resistance. So this is for parallel circuit and this is for series circuit. So the current flow through the 1 ohm resistor is going to be 3 ampere. Secondly, we are going to find the voltage drop across the 1 ohm resistor. So 2 ampere times 1 ohm is going to be 2 volts. So the voltage is going to be 2 volts. And we are going to apply this equation for finding the power. And the power dissipated in the 1 ohm resistor each second is going to be 4 watts. The light bulbs connected in the circuit have identical resistance. Rank the light bulbs in order from brightness to dimness. So, brightness is determined by the power dissipated in the bulb. Power needs to be considered. All of the bulbs have the same resistance, so their brightness is determined by the amount of current flowing through them. All of current flow through light bulb 1 is separated to 2 and 3 and 4. Current will take the path and least resistance, so more current will flow down the path leading to bulb 2 than the path leading to bulb 3 and 4. However, the exact same amount of current will pass through both bulb 3 and 4 because they are in series and receive the same current. As a result, bulbs 3 and 4 will have the same brightness. So the brightness of bulb 1 is the greatest, and the brightness of 3 and 4 is the same. What's the resistance of R1? What's the potential difference across R2? What's the power dissipated of R3? So we are going to find the resistance of R1. So the R1 is going to be 2 ohm. Secondly, we are going to find the battery voltage. So the potential difference across R2 is going to be 2 volts. And we are going to apply this equation for finding the power. The power is 6 volt times 1 times 5 ampere, so the power is going to be 9 watts. What current is flowing through point P when switches X and Y are closed? What current is flowing through R1 when switches X and Y are closed? Switch Z is closed. How much power is dissipated in R3? So we are going to resistance. So we are going to find the resistance for the parallel circuit. So the current is gonna be 1.5 ampere. And we are going to find the current flowing through R1 when switches X and Y are closed. And the current is going to be 1.0 ampere. And we are going to find the power. And the power is going to be 60 watts. What's the current flowing in the circuit initially when the switch is open? What's total equivalent resistance of the current when the switch is closed? The resistors in the circuit are actually light bulbs. When the switch is closed, how is the brightness of light bulb 1 affected? So we are going to find the resistance for series circuit. So the current is gonna be 1 ampere. And we are going to find the equivalent resistance. And the equivalent resistance is going to be 2 ohm. Closing the switch creates a new parallel path through R3 where voltage can be applied and current can flow through. This parallel path does not affect the current flowing through or the voltage across resistor R and R2 as they are on a separate parallel path. So the brightness of the light bulb R1 remains the same. About brightness of light bulb, power determines the brightness and current determines it also. So power determines the brightness and the currents also determine the brightness. An electric circuit with a resistor R connected to a battery. If EMF of the battery is tripled while R is held constant, the power dissipated in R is. So the power dissipated in R is gonna be this is gonna be tripled. The voltage is gonna be tripled, and so this is gonna be the answer of this question. What's the value of the unknown resistor? What's the amount of power is dissipated through the 2 ohm resistor? So we are going to find the value of the unknown resistor. This and the resistance is gonna be 3 ohm. And we are going to find power and we are going to apply this equation. So power dissipated through the 2 ohm resistor is going to be 4.5 watts. 4.5 watts. The diagram shows an electric circuit containing 3 resistors. The ammeter read with 5 amperes. What's the voltage across R3? What's the current in R1? So we are going to find the answer of this question, and the voltage is equal to the current measured at the ammeter. So you can find 50 volts as the answer of this question. And secondly, because R1 is equal to R2, so I given is developed evenly So you can find 2.5 ampere is going to be the answer of the second question. What current will flow through the 250 ohm resistor in the current? So we are going to apply this equation. So the current is going to be 40 microampere. What current will flow through the 4 ohm resistor when the switch is closed? What's the total equivalent resistance of the circuit when the switch is closed? What is the total power dissipated in the circuit when the switch is closed? So we are going to find the resistance of parallel circuit. And the total current is gonna be this. So the I2 is gonna be 1 ampere, and the resistance is gonna be 4 over 3 ohm. And we are going to find the power. So the power is gonna be 12 watts.